All right. Hello. Good evening. Hi, Jala. This is our November week 4. So how was the trial? How was the trial? I heard something about the trial. Uh, I heard hollow and compact tube came out for your experiment. Uh, the writer no Why? What's up? Maybe paper two Paper two Okay, okay. Why? What's up? What's up? What's up? Maybe it's not as bad as you think. All right. Hi, Shaira. How are you? How's the trial? How's the trial? I heard something. Oh, I heard electrolysis didn't come out any, right? I kind of expected lah. Like I said. What else did I hear? I heard okay, the compact and hollow tube came out for the experiment. I heard oh shit, what else came out? Isotope. I heard isotope came out. I don't know lah. All in all, I have students telling me the paper is okay. Most tell me it's okay. Not too hard, but can do. All right, so guys, now that your trial is over, it was okay. Okay, cool. What are you having for tomorrow? What subject is tomorrow? Or there was no paper. There will be no paper tomorrow. All right. So let's continue with our revision, shall we? Hang on, guys. Let me take this away. Okay, I think we were here. Oh, no papers tomorrow. I see. Okay. So I assume your trial is almost over, right? Should be almost over, right? I mean, most of the papers are already done, huh? All right. So now it's time to focus on SVM, huh? You have one target ahead now, right? So this trial kind of gives you the feeling of, how would you do in SVM? Of course, trial is gonna be harder, all right? Wow, Tiala, you actually remember? Inertia BOD. Oh yeah, BOD came out too, yeah, I remember. Okay. And I assume inertia should be okay, right? Inertia should be easy, right? BOD, the one is a bit hard. Okay, if your reverse BOD is high, that means it's polluted. Okay, so guys, let's continue on chapter 12, shall we? Okay, let's continue with this. I think we finished our medicine last week. So no medicine came out. I mean, I will assume too lah. All right, so let's go to our nuclear today. Okay, this is a very easy chapter. Okay, I'll just jump straight to the point. Okay, so the advantage of nuclear, why do we use nuclear? Number one, it is used to replace petroleum, or you can say to replace fossil fuel. Okay, menggantikan bahan api fosil, which is your petroleum, your coal, and your natural gas. Right, we are still very reliant on petroleum now. If we use nuclear, then we don't need to rely so much on it. Okay, and then next, it produces a greater quantity of energy. It gives you a lot of energy rather than just petroleum, like a very little. Guys, compared to petroleum, nuclear gives you a few million times more. A few million times more, right? So nuclear is so much better, right? Or you can say it's more efficient. Okay, this third one I'm gonna skip. And then number three, it releases very little greenhouse gas, or you can say it doesn't produce CO2, right? Because nuclear, they don't burn things, they don't use oxygen, they don't produce carbon dioxide. So basically, you don't create greenhouse effect, right? Compared to petroleum, okay? Compared to nuclear, okay, let's not talk about the waste, but the exhaust, okay, the byproduct, petrol just gives you so much more carbon dioxide, but nuclear gives you nothing. Okay, nuclear is like clean, right? Besides the waste lah, okay, we have no idea how to handle the waste, but other than the waste, then the reaction itself is very clean. Okay, so again, replace fossil fuel, a lot of energy, very little greenhouse gas. I mean, these 3 points alone are like winning points already. Okay, so what is the bad effect? Number one, you have waste, right? We have no idea how to handle the waste because the waste is radioactive. Next is high cost. It's going to be expensive because the nuclear fuel is very expensive. And then we can use it to make weapon, okay, in case we misuse it. And of course, it's non-renewable, right? Just like your petroleum, nuclear is finite. Nuclear is limited. Once we finish it, there will be no more. All right, which brings me to the main point here, guys. This is the main point of this chapter. We have two types of nuclear reaction. Okay, we have nuclear fission. This is pembelahan nucleus. And then we have nuclear fusion, pelakuran nucleus. All right, which is the guys, they are just opposite of each other. You see, fission is to use one big one split into two small one. One big, two small. Okay, fusion is the other way around. I use two small one, I combine it to become a bigger one. So two small to become one big. Right? So you see, fission is one big, two small, one big, two small. Fusion is two small, one big. Okay, one is splitting, one is joining. Okay, so we look at the splitting first. Fission, we use something called uranium-235. This is the fuel. This is what we need, right? Cannot be anything else. Okay, you might say, sir, I cannot use uranium-238, man. No, doesn't work. Plutonium, doesn't work. Uranium works the best. Okay, uranium-235 works the best. And unfortunately, Malaysia, we don't have this. We don't have uranium-235. So if we want uranium-235, we have to buy it from other countries. Okay, we have to buy it from Russia, let's say. Okay, so it's a process of splitting heavy to two nuclei. Okay, and then guys, can you see what's happening here? I use one neutron and shoot this big uranium. Okay, neutron to shoot this, and this thing will break into two. All right, and then this gives you a lot of energy. This is nuclear energy to be exact. Okay, nuclear energy, because nuclear reaction gives you nuclear energy. All right, and then here's the main point, guys. Here is the main point. I shoot it with one neutron. It gives me back 3 neutrons. And then this 3 neutron will hit another 3 uranium. And guess how many they produce? Guess how many they produce? 1 becomes 3, 3 becomes 9. You see, this is multiple of 3. All right, and then 9 becomes 27. 27 becomes 81. Can you see this is like a more and more and more and more? Right, sort of like a pyramid thing lah. All right, so this is what we call a chain reaction. Okay, tindak balas berantai. Okay, because it's like a chain. 1 becomes 3. It's like telling rumor to 3 friends. Okay, you gossip to 3 friends, and then that 3 friends will each go and gossip with another 3 friends. So before you know it, it's spread everywhere. Just like spreading COVID. You spread your COVID to 3 other people. These 3 other people, each of them going to spread to another 3. So 3 becomes 9, 9 becomes 27, and so on. Okay, this is called chain reaction. Okay, can I think you guys learned this before, huh? All right, and then just an add-on for you. If this chain reaction is controlled, terkawal, that means we do this in a slow way. We don't let this chain reaction go crazy. We do it in a chill way. This, we use it for electricity. Okay, we use this for electricity. That means if you go to any nuclear reactor, you go to any power station that uses nuclear, they are doing controlled chain reaction. All right. Whereas an uncontrolled chain reaction, if I want this thing to go crazy, if I want this thing to go gila, to produce as much energy as I can, this is what we use to make weapon, to make bomb, right? Basically, uncontrolled chain reaction is in atomic bomb, right? Because if let's say I'm US, I want to bomb Japan, I want to bomb Hiroshima or Nagasaki, I want this thing to be as crazy as possible. to release as much energy as possible, to kill as many people as possible, right? Right? Because my job is to kill. Okay, so if this is controlled, if this is controlled, terkawal, this is for electricity. We want electricity to be slowly, steadily released, right? If this is uncontrolled, tak terkawal, this thing goes crazy, you will get a bomb. Okay, so this is the danger about nuclear, you see. If I'm doing controlled reaction to produce electricity, if somehow the safety feature broke, okay, the safety feature broke, this thing will go from controlled to uncontrolled. Basically, my nuclear reactor, my nuclear power station will turn into a bomb, right? So this is what we are most scared of. But of course, guys, it's not that easy to do, right? Nuclear is actually quite safe. Okay, I'll talk about that later. Okay, and then next, of course, let's look at fusion. Okay, fusion. This thing, we don't use it because it's too difficult to do. Guys, fusion only happens in one place, which is the sun. Okay, which is the sun. All right, so can we use this to make bomb? Yes, we can. Can we use this to make electricity? Yes, we can. In fact, guys, guys, pay attention. Fusion gives you more energy than fission. Fusion is actually better, right? It gives you more energy. And of course, can you see? Fusion is much simpler and it only gives you helium as the waste. This is the only waste. So fusion doesn't give you radioactive waste. This is much easier to clean up. Okay, whereas these two, they are waste. We don't know where to throw them. So you might say, then sir, fusion is so good, right? It's cleaner, it's more energy. Why don't we use it? Because our technology doesn't allow. We have no technology to use fusion because it's too. First of all, you need very high temperature, like few million degrees Celsius. Second, you need very high pressure, and these two things will cost you a lot of money. So this thing, it doesn't make sense to do yet. For now, we can't use fusion. In the future, maybe. I don't know. Maybe we will use fusion power in the future. That's wishful thinking. All right. So guys, fusion is they produce more energy. This is better than this. Of course, the sun is better than us. The sun gives us more energy than we can ever imagine. Isn't it? Isn't it? So the sun just is just better, right? The sun will just trump any power station, any nuclear power station. The sun is simply better. All right, guys, think about this. Think about this. If we want to do this on Earth, basically we are creating a sun here. We are creating a mini sun on the Earth's surface. Do you think that's possible? I mean, it's not impossible, just very difficult. Okay, maybe in the future, I don't know, I'm just, you know, guessing. Okay, how future is future? Maybe 200 years, maybe 20 years. I don't know. Right. Anyway, so let's talk about generation. Okay, so for now, we just use fission. Can you see uranium? Can you see uranium? So this is fission. I don't care which country you go to, most of the power station is going to look this way. I would say all power station will look this way. Right, guys, pay attention to these two. Pay attention to these two. Now we are generating electricity. Now we are making electricity. We want it to be controlled, isn't it? We want it to be terkawal, isn't it? We don't want it to explode, isn't it? So these two guys, their job is to slow this down, right? Both their job is to slow down the nuclear reaction. Okay, the nuclear reaction. So how do they do it? How do they do it? They do it to the neutron. Okay, they do it to the neutron. Imagine this, guys. Imagine this. 1 becomes 3, 3 becomes 9, 9 becomes 27, 27 becomes 81. Imagine now I have 81 neutron. If, let's say, 20 of it, I slow it down or I take it away, the chain reaction is going to slow down, isn't it? Again, if I have 80 neutrons, I take 20 away or I slow 20 down, the reaction is going to slow down. Right? Right? So this is their job. You see, boron's job, this boron controller, the job is to absorb neutron. Take it away. right? Graphite, you see, can you see the name? Can you see the word moderator? Can you see the word moderator? Guys, do you use Discord? Do you use Discord? You know what's a moderator's job? A moderator's job is to slow you down so that you don't simply say, is to control you lah, basically, right? So that you don't say any stupid bullshit there, right? So if you use a Discord, that is, right? So a moderator, their job is to slow things down. So you see, slow down the neutron. So both these things, they are quite important, right? One is to absorb, one is to slow down. Because if these two things fail, guys, can you guess what happened? If these two things fail, this reaction will go from controlled to uncontrolled. You get what I mean? This thing will become uncontrolled, and basically this thing turns into a bomb. This is how explosion will happen, right? This is how explosion will happen. So guys, before you freak out, these two things they are actually quite hard to screw up. Okay, they are actually quite hard to screw up. If you are using the latest technology of nuclear, these two things they have many backups to it, right? They have many backups to it. It's like, okay, let's say now you have a car at home. Your family only has one car. You guys are very scared of the car breaking down, isn't it? Okay, you guys are very scared of the car breaking down. So what do you guys do? You buy another car as a backup, right? Will their second car break down? Maybe, but the chance is very low. Okay, so just to be safe, you buy like 5 cars. I mean, it's very silly lah. But imagine you really don't want it to fail. You really don't want your car to fail, so you buy 5 cars. If the first car fails, you have the second one. If the second one fails, you have the third one, then the fourth one, then the fifth one. There is almost 0% you have no car to drive, right? So our modern nuclear reactor is exactly like this, right? It has like 5-6 layers of boron and graphite. Will this thing fail? Yes, but the chance is really small, right? If you do proper maintenance, if you hire the right engineer, if you do it in the correct way, this thing has almost 0 chance to fail, right? You might say, then sir, what about Japan? What about Japan? What about Fukushima? So you see Fukushima explode what? That thing exploded because of natural disaster, because their cooling tower failed. This thing didn't fail, right? It's because of the earthquake, because of the tsunami, right? If nuclear is in Malaysia, there is almost no way this thing will fail, unless we are stupid enough to make it fail lah. Right? Because Malaysia, we have no typhoon, no hurricane, no earthquake, no volcanoes, no tsunami, no nothing, none. Right? There is 0 chance this thing can fail unless a terrorist come and bomb us lah. Right? When's the last time Malaysia got bombed by a terrorist? Not really, isn't it? So Malaysia is actually quite safe to use nuclear. Okay, but then we don't use it because Malaysia, our fossil fuel is too cheap. Our petroleum is too cheap. Our natural gas is too cheap. So Malaysians are like, why you should use nuclear for what? You see, so Malaysia, we're very lucky because we are blessed with a lot of natural resources. There's no need for us to use nuclear. Okay, guys, last thing I want you to remember, it's the energy change, right? It's the energy change. Okay, we start from nuclear energy. And how does this thing work? This thing is used to heat up water. To panaskan air. So this thing will become heat energy. Okay, tenaga haba. And when water gets hot, it turns into steam. All right, steam has high pressure. It will spin the generator. Okay, as the generator moves, this is kinetic energy. Tenaga kinetic. Why kinetic? Because this thing is moving. Right, it's just like your bicycle generator. You cycle, the headlight comes on. Okay, so this thing you move, so you have electricity, and then you will get electrical energy. Okay, tenaga electric. So you have 4 energy change here. Guys, please do not get this wrong. I repeat, please do not get this wrong because this is so damn easy. Okay? Make sure you don't get this wrong. It's just energy change. All right, so the next page, this one, please read it yourself. Please read it yourself. This is like K-Bar stuff and out of syllabus stuff. Why do we use nuclear? Blah, blah, blah. Alright, so we are going to skip this. Guys, do you have any question? Do you have a question? Did this come up for the trial? Paper 1? Did nuclear come up for paper? I'm sure there's 1 or 2 questions, right? Oh, paper 2, is it? So what did they ask? What did they ask? Cheryl, what's your school again? Cheryl, where's your school again? Are you under Selangor or are you under Wilayah? Because it's different paper. Oh, you're Kota Kemuning. Okay, I see. Oh, okay. Oh, that means okay, I see. Okay, that means Selangor paper. So, oh, this thing came out. Okay, cool. Guys, now that you have gone through your trial, now that you have gone through your trial, tell me something. Tell me something. I did tell you that in trial, right, all the chapters are going to come out. Isn't it? Maybe not all, but 80%. Right? Did it? I'm sure it did. Paper 1 at least. Paper 1 is equally distributed. Almost all chapter is going to come out. Right? This is why I say the key in getting A for science, in fact, all subjects, the key in getting A is to be okay at every chapter. You get what I'm trying to say? That means every chapter, you're not too good, you're not too bad. You're okay. Boleh tahan. Okay? Boleh je. Okay? Not as in ridiculously bad or like really good. I mean, of course, really good is a good thing, but there's no need. You just need to be okay at every chapter. That's an A for you already. I don't want you to be really good at one chapter. Let's say genetic, you are super like mantap. You're good at it. And then chapter 6, which is the joint one, the sendi one, you're like, okay, this chapter I langsung tak tahu. Please don't do that. Right? That's why when my students always ask me, sir, which chapter should I focus for SPM? I will give you this answer that you feel like slapping me. Study all. Okay? That day there was a student asking me, cikgu nak baca mana? Nak baca bab mana? I say baca semua. Okay? The look on everyone's face will be like, sir, you serious? Might as well you tell me nothing, right? Because that's the truth. I want you to study to be okay at everything, but I don't want you you see many students, they just read the chapters they like. Okay, like they like genetics, so they read genetic. Like chemistry stuff, they hate it, so they don't study. Please don't do that. Please don't do that. You should be okay at every chapter. Okay, I hope you get what I'm trying to say here. Anyway, let's go to our exercise. Okay, there's not many to do here actually. Okay, let's go to page 22. Page 22. Okay, since it's after your trial, I'm just gonna take it easy lah. Okay, so advantage. Okay, I did mention this already. Do not emit greenhouse gases. This is called gas rumah hijau. That will pollute the environment. Yang akan mencemarkan alam sekitar. Okay, so there's no greenhouse gas. There's no gas rumah hijau. Next, do not produce of waste, I guess. Bahan buangan. Okay, or you can say pollutant, bahan pencemar. I'm okay also. You see, if you use nuclear, you don't get dust, you don't get soot, you don't get ashes. These things, you get it from your fossil fuel. You burn coal, you burn arang batu, you're for sure getting this tree. But nuclear, no such thing. It's because fission is just splitting. Where do you get the dust? There's no dust. Right, so number 3, only a what quantity? Only a small quantity is needed to generate a large amount of energy. You just need very little nuclear to get a lot of energy. Okay, untuk quantity yang kecil untuk menjanakan jumlah tenaga yang jumlah besar. Okay, as in really besar, really besar. Like I said, nuclear is a few million times, okay, berjuta-juta kali ganda of your petroleum. Why not use nuclear? Okay, you see, many people they ask me, sir, since you say nuclear is so good, right? Why don't we use nuclear? Because of fear lah. Because of fear, people are scared. You see, people are always scared. People just, you see, this is how news they sell. Whenever you read the news, guys, have you? This is I don't know whether you know this. Studies show that the more you read the news, the more depressed you become. Have you realized this? If you are a person who always follows the news, it just makes you sad. You see, our news, they don't report the good things. Or they don't say, oh, there's something new coming out. No, no, no. They just report bad things, okay? Some bombing happened somewhere. 3 people died, okay? Plane crash. 5 people died. They they need someone to die to sell news, right? They can't tell you boring stuff like, oh, there's actually nothing happened in this place right now. See, no one wants to read that. They want sensational title. So whenever there's a nuclear disaster, wow, you'll be damn sure they will report everything about it, and then people will get scared, like, oh my god, nuclear is bad. Right? So this is to reduce the use of fossil fuel. Okay, mengurangkan penggunaan bahan api fosil, so that you don't burn so many things, right? So next, cost. Okay, this is the disadvantage. Cost is of, sorry, the cost of building a nuclear power station is high. Okay, cost yang sangat tinggi. It's expensive. Expose the worker. Okay, if you work there, you'll get more radiation. Okay, to hazardous radioactive radiation. Sinaran radioaktif. Okay, you get more radiation. What maintenance is required? You require regular maintenance. Okay, penyelenggaraan yang berkala, just like maintaining your car. You need to service your power station. It's required to prevent leakage, pembocoran, so that I don't leak radiation to the environment. And then what of radioactive radiation may bring harmful effect? Okay, the leakage or same thing. Okay, and cause death, menyebabkan kemautan. You can say cancer. Cancer is the most obvious point lah. Radiation gives you cancer. Okay, next. Guys, I'm not gonna do this. Okay, 2 use of nuclear energy. I just said it already. Electricity and bomb, nuclear weapon. Okay, I'm gonna skip. See, waste released to atmosphere. Coal, arang batu will give you carbon dioxide. Dust, sulfur dioxide. Nuclear will give you nothing. Okay, we can use coal for another 150 years, but nuclear we can use it for another 600 years. See, that's why we use nuclear. Okay, I'm gonna skip this. Let's do the main question instead. Okay, so let's look at number 4. Uranium-235. One big becomes 2 small. Okay, so this is your nuclear fission. Pembelahan nuclear. So what is X? What do we use to shoot the uranium-235? We will use neutron. Let me explain this. Many students have problem remembering this. It's actually very simple. Why don't we, okay, we have neutron, proton, electron. All right. Why do we use electron? Electron is very small, too lightweight. You shoot this, no feeling, nothing's gonna happen. Next, proton. Proton is positive. Inside here, you see the black color ones, okay, they are all positive. They are all proton. How can you use proton to shoot proton? Positive, negative, sorry, positive, they are going to menolak. Okay, they are going to repel. It's just like your magnet lah. North and north will push each other away. Okay, north and north will push. So of course I don't want this to happen. I want something that has no charge. So what is no charge? Neutron law. So I use neutron to shoot this. Right, so C, what is the function of X? What's the function of this? This is to shoot this thing. You don't say shoot, you say bombard. Bombard the uranium-235. Okay, how do you say bombard in BM? How do you say bombard in BM? I have no idea. Okay, guys, moving on. Based on the diagram above, name the energy produced. Okay, what energy are we getting? Like I said, the first foremost energy, this is a nuclear reaction. A nuclear reaction will give you a nuclear energy. Right? One benefit of the energy. So the benefit is it is in large amount. Okay, jumlah besar means you get a lot of it. Okay, guys, like Slovakia, this country nearby Russia. I don't know whether you heard of this before. Slovakia, they use nuclear, but their country is a very small country, so they cannot finish the electricity. So what do? They sell it to their neighbors. They sell it to their neighbor country. Right? So imagine we do this. Imagine we use nuclear and then we cannot finish the nuclear, so we sell it to Indonesia. We sell it to Thailand. Is it good, right? Right, so what reaction is this? This is your chain reaction. Okay, tidak balas berantai. Alright. Okay, so can I let you do some question? Can I let you do some question? Okay, I know your guys, I know your trial is over, but do some exercise with you. Right? Don't just let me do everything. Okay, can you please try question 5 and 6? Just two questions. Just two questions. 5 and 6. Okay, 5 and 6, it's almost the same question as just now. Right? You see, in fact, 4 and 5 is almost the same. Alright, guys, you may start now. Please let me know when you're finished. I'm just gonna be here and wait for you to finish. Okay, please start now. Please continue doing right now. Okay, I'll be waiting here. Okay, I put off my mic for now. Okay, hi guys. Let me give you the answer for number 5. Alright, so this is the same question. What is process X? This is nuclear fission. Okay, pelakuran nucleus. Particle Q is again our neutron. This is the same question. This is the reactor question already. What is the radioactive element for reactor Y? What do we use as the fuel, as the bahan api? That would be uranium-235. Okay, process which generates heat energy. How do we use this to produce energy? Basically, it's nuclear fission lah. It's the same thing. Okay, the nuclear fission. Flow map to show energy change. Like I said, we start from nuclear. Okay, becomes heat, harbor, becomes kinetic, becomes electrical. All right, simple. Next, number 6. What is this? This is your nuclear fusion. I'm just gonna write fusion here. Pelakuran nucleus. What is the energy? Again, nuclear energy. One condition required. Okay, why? Like I said, this happens in the sun. What makes this so difficult? Because you need high temperature, suhu tinggi, or high pressure, tekanan tinggi. You need it to be really hot, to be really compressed to happen. One place where it happens naturally, the sun, matahari. Okay, we skip E. This is not important. Guys, are you okay with this? Are you okay with this? Did something like this come out for exam? Because if it comes out in exam, this is what you see, I think. Okay, so number 7, let's look at the generator. Let's look at the reactor. And we can call it a day. What is the use of the control rod? Okay, guys, can you see these two things here? Like I said, this is the main guy. These two is what help the thing to slow down. Okay, to control the rate of reaction. Okay, so what's the use of the control rod? This is to control the rate of nuclear fission. Okay, so that fission slows down. It doesn't do so much. Explain how the control rod performs its function. Okay, what does it do? It absorbs. What does it do? It absorbs the neutron. This one you need to memorize. Control rod is to absorb the neutron. The moderator, the graphite moderator, is to slow down. Like I said, your Discord moderator is to slow you down so that you don't say something offensive. One element to make control rod, what is used to make control rod is our boron. Okay, boron. So nuclear energy changes to heat, changes to kinetic. This one we already know. C, water is commonly used as the cooling agent. Okay, this one I think I didn't really mention it. Okay, what is this thing for? This thing is to basically cool this thing because there's so much hot water, we cannot control it. Okay, we have to get rid of the extra heat, so we do this. This is the cooling system. Okay, so why is the cooling system very important? This is to cool the reactor. Okay, untuk menyejukkan reactor. What happens if this system fails? If the reactor fails, you are gonna get your reactor failure. It's gonna melt down. It's gonna explode. Okay, you are going to have a nuclear disaster. Okay, you will have kemalangan nuclear. So Fukushima failed because of this. All right, Fukushima failed because the cooling system failed. So why did it fail? Because of the tsunami, like I said. If there was no tsunami, they would be fine. You see, Japanese, they are really good in industry. They are really good at technology stuff. So it's not their fault when it fails. It's because of the tsunami. Right? They did their best to to do something against the tsunami, but it wasn't enough, so the thing failed. All right, so it is the same question I'm not gonna do, huh? The rest of it is like K-bar already. Just two questions here. You want, you can do it yourself. Guys, the answer I will put it in GC. You want, you can check it yourself there. All right. And then just a reminder, guys, just a reminder. Next week is gonna be December. We are going to use a new note. And again, another reminder. I just want to let you know next month, December, we are only going to have 3 weeks class. December week 1, week 2, and week 3. And then week 3, you're attending 2 classes, right? 3 and 4 is together in 1 week. So the next week, which is the 3rd week, is gonna be a bit tiring because you are attending 2 classes for every subject. Because the following 2 weeks is gonna be a holiday. Okay, I'll let you know now. For now, okay, the schedule, you'll know it soon. The schedule will be sent to you soon. All right, so guys, hope you did your trial well and hope you get ready for your holiday, rest a bit, and we go again for SPM. Okay, so guys, I will see you next week. Have a good one. Take care, see you, and bye-bye.